So my voice is audible, I think. Can someone answer?
Yes, sir.
Okay, thank you. Thank you very much.
Yes, sir.
Okay, thank you, Nanda. So last class we discussed about how the Hadoop system came into a picture and how this project was developed. So in this data era, we every person and everyone, every mission or every system is producing much data as much as, so large amount of data is producing. So if it is producing, so how we want to analyze this data, and how we want to store the data, and how we want to use this data for future purpose, a future analysis, whatever that in the subject oriented we can call as a business intelligence. So if we've done something about data, and if the result how much useful to the end users, not only for example if my data is useful for myself only, it is not going to be like that. Maybe for example my reviews are going to be used for others to buy such products. My valuable feedback will be used to better boost up any product or any customer. So any like that, so it is not going to be used. So our data, how it is going to be used for others, end users, how they are going to be treat our data in a better manner. So everything is there. So simple for that example only we discuss. So one person, a photographer, how he is going to be store a data, and how he is going to be managing the data service. For that only one large. Nowadays we can see that in a previous days in 19th century, that is 1990 all of. So we don't have any camera phones. We have only land phones. So that time we have, if we want to take a photograph, what we have to do? We have to go to a studio, or the studio camera person will come to home. We will take it. Nowadays, is that every person is going to be studio for taking a pic, even if the mobile itself is having a high megapixel cameras, and still we are loading, we are taking a pics, and still we are loading that into a physical or any domains, maybe a Google Photos or any others domains we are going to be storing. Are we physically storing also? Even if physically storing also, it needs some of the data management. For example, if you are going to be lost your data from your physical system, that also even we can recover by your recovery management. So that is only, so that much of powerful technologies are there to store and retrieve the data in a very serious manner about that. So think that, so for example, you buy a memory card in 2010, now it is 10 years gone. Still you can get back your 2010 deleted data, or what the data you are organized, managed, everything you can get it from there. So please think over that, how much possibilities are there to retrieve or see the data. So we need to take care about the data processing and data storage also. So that's why only we are saying that um, data analytics, big data analytics is a problem, and for that we are giving a solutions for data mining. So here we are going to be think about problematic manner, how we are going to be uh, see about the data. If the data large amount of data is there, then how we want to think, and how we want to protect and produce a best result to the end users. So that's only here we want to see about everything as a question wise. What will be happen, why it will be. So like that, like the way we are going to be think all this. And today we are going to be see about how Apache, Hadoop, and Hadoop ecosystem. So all those Hadoop is known for the MapReduce and its distributed file system HDFS, renamed as NDFS. Also, you can network file system, network distributed file system. Also, so previous it was a network distributed file system. Now it is came into a HDFS, Hadoop distributed file system. The term is also for a family to related to the project to fall under the umbrella of infrastructure for distributed computing and a large scale data processing. So we know about data size is very high, so that only we are going to be use a large scale of data. So all those these core projects are invented by the book hosted by Apache Software Foundation, which was produced to support for a community as often open source software projects. So including that original HTTP server also, from which gets a rename, which gets its name, and as Hadoop ecosystem grows, more projects are appearing, not necessarily hosted by at Apache, which provides the complementary services to Hadoop to build core and high-level abstractions. So we know what is abstraction, data hiding. The Hadoop projects are covered in this book briefly here. So one is about common, a set of components interfaces distributed file system, general input output, serialization, Java, remote processing, control, and persistence data structures. So all those things. And the second one is about serialization system for efficient and cross-language RPC and persistence data storage also. And another one is about MapReduce, a distributed data processing model and execution environment that runs on a large cluster of commodity missions. Large clusters of commodity missions. So you know what is a commodity mission? So that is a basic hardware systems which we are going to be used at a cheap level, very cheap. How we are going to be get it? So then another one is about HDFS, a distributed file system that is a large clusters of commodity missions. How we are going to be analyze from the distributed file systems, and we have to run it on the Hadoop system. So then another one is about pig. What is it? Is a one language, data flow language and execution environment for exploring very large data set. Pig runs on HDFS and MapReduce clusters. So where we are going to be run on. So we know the various types of running a pig. So generally we can run through the terminal, or we can run through HDFS base, and we have three types of running of pig Latin statements also. Then another one we know recently we discussed the Hive, Apache Hive. So it is provided for data warehousing, distributed data. So we know that the data is various structures are there. It may be a structure, semi-structure, and unstructured data. So if these type of data, if you want to store in a data warehouse, so either if you want to process the data, again we need to recall the data and reprocess the data, large amount of data, and it is takes much time to understand the patterns, everything. So that only while we are storing the data warehouse itself, we need to modify the data and we need to store in a structured way. So that's why only it provides a such structured way to store in data warehouse. And Hive manages the data stored in HDFS and provides a query language based on SQL. That is a HQL we may call this, uh, and which is translated by a runtime engine to map reduce jobs for querying the data. So then another one is this HBase and Keeper and Snoop. We are not going to be discussing in our syllabus, but you have to know it what its general name. HBase is it is a distributed common column-oriented database. Then HBase used HDFS is underlying the storage, and it supports the both batch-style computations using the map reduce at the point queries, random reads. How we are going to be. Then another one about Zookeeper is used to distributed highly available coordination services. Coordination services, however, Zookeepers provides the primitives such as the distributed logs, and it is to provide the building distributed applications, how we want to build applications. For example, simply if you are learning one simple C language, how you are learning, or Java or Python, whatever it may be you are learning. So generally how we are going to be do a programming level, how we are going to be manage the data. So that same type of thing here, which we know about Hive and Fig, it is going to be provided. So if you want to build an application on this HDFS platform, so this Zookeeper is going to be helpful to build an application, distributed application. Then another one is about Scoop, a tool for efficiently moving the data between the relational database and HDFS. So how we want to transfer and move the data in between. So we already know that in Hive we are going to be transfer the metadata from metadata to process, and these metadata is going to be called by the HDFS system. So even if there we have the JDBC and ODBC connections, so in order to process the local file systems to uh, manage it. So that relationship, so if we want, we need this is scope is going to provide the efficient tool for moving the data between the relational base and HDFS. So why we are again we are going to be talked about the moving, and so thing means, for example, we already know that in the previous days, if you want to transfer data from uh, a simple hard disk to, for example, any even a CD or DVD, if you want to copy or if you want to move the data, is going to be take 12 MB per second like that in the previous days. Now we have copying the terabytes of data in 100 to 200 Mbps. So that's when we saw yesterday. So the data is growing very fast. Same way, the data processing also has to be very fast, and transferring the data also very fast. So if you want to move the data, so if you want to move, definitely we need to have an exact data. So again we need to consider about moving and copying. So the moving is provides complete data over at our destination only. So we don't have any data in a physical source places. So that's only we need to consider about whole data, how much feasibility and how much fast and how much reliability. So we know that what every reliability, feasibility, flexibility, all those terms we know that. So we need to provide this facility to the data such that we are going to be moving very fast and efficiently. Then this is Hadoop releases versions how it was released. Hadoop releases how it is done, and how it is 0.0 to 0.3 series is being. So this is a at another resource navigator. So what is a? I think a lot of time we have heard this one. What is the meaning of earn? So now tell me. So for example, we can simply call Hadoop, for that we are going to be shown as a elephant picture now. So for example, what is the general meaning of earn? What is earn? Can anyone know that? Earn. What we will call earn? మామూలుగా తెలుగులో కానీ ఎక్కడ మీనింగ్ ఏమంటారు? ఎర్న్ ఏమంటారు? If you want, you can Google it and you can tell me. So that is ఎలా చెప్పాలంటే, ఒక తాడు కానీ థ్రెడ్ కానీ లేకపోతే తాడు కానీ ఒక ఉండ అనమాట. ఒక రౌండ్ గా చుట్టిన ఉండని థ్రెడ్ ని జనరల్ గా ఇప్పుడు లేడీస్ కానీ హ్యాండ్ వర్క్ చేస్తాను కదా, అప్పుడు ఆ కలర్ థ్రెడ్స్ అనే ఒక ఉండగా వస్తాయి కదా, దాన్ని మామూలు జనరల్ గా ఎర్న్ అంటారు. So that how we are going to be navigate. So here the names are very real life words on it. The Pig, Hive, for example, Hadoop, all those things are very familiar words only. For example, I will tell you how the Hadoop name comes into a picture. I think the place somewhere I read that one. So I will tell you. So one second, I will tell you how the Hadoop name comes into a picture. So don't make noise. I'll get that one. That one I am searching for that. So his daughter like very much a yellow elephant. So that Don Cutler is developed this Hadoop system. His daughter very much likes yellow elephant. So the from that name only he is put as Hadoop. Okay, whenever I saw it, I will send you through WhatsApp to that name, how it will came to name. Okay. So see this one I think so. See this, the name Hadoop is came into non-acronyms. It made up of name the project created by Don Clutter. For example, how his name came to be about. The name my kid gave a suffered yellow elephant. Short, relatively easy to spell and pronounce it. Meaningless, it is not and used anywhere else. So these may naming criteria. For example, kids are good at generating such that. So Google is a kid terms. So how we are going to be called Google. No? So that is a kid terms. Generally how they are going to be pronounced it. అంటే ఎలాగంటే చిన్నప్పుడు మనకి ఒక వర్డ్ చెప్పామంటే వాళ్ళు వెరైటీగా మాట్లాడుతుంటారు కదా, వెరైటీగా మాట్లాడతారు అంటే క్లియర్ గా వాళ్ళకి ప్రొనౌన్సియేషన్ రాకుండా ఎలా మాట్లాడతారో అలా వచ్చిన వర్డ్ అన్నమాట. సో ద డాంక్ కటింగ్ హిస్ డాటర్ ఈస్ యూస్ టు టాక్ ఎల్లో ఎలిఫెంట్. So that name is came into picture here. So such sub projects contributes the model in Hadoop is also trends have a name of unrelated their functions. Often it is an elephant or another animal like pig. So how they give names for pig and hive, how such names. So similar the components are given to the descriptive and rather than the nuance names. There is a good at principles that means it generally works out what something does but from its name. For example, the job tracker keeps a track of the map reduce job. So like that. So instead of giving formality names, they are going to be give general terms how to call the projects. So that is a simple introduction to how the name came. So okay, I think it was in the next page only. Okay, before going to be see this, we want to know about how these systems are. I already told you there is a different meaning of Hadoop is initially started with um, Yahoo, and it is later the project is handed over by Hadoop, Apache system. So this is the releases. Then HDFS Federation. So this is versions how the Hadoop system is released. So a new map introduced to and implemented is called N at another resource navigator, which is resources to management systems to running the distributed applications. So MapReduce 2 releases the classic and run the previous releases also to describe the more depth of N MapReduce. And we will see that on the next pages. Then Hadoop HDFS Federation, which partition with HDFS namespace across in the multiple name order to support the clusters with very large number of files. So next version is federationism. Then HDFS high availability, it removes the name nodes in a single point of failure and supporting the standby the name node forever fail over. So for failure. So this, features of these Hadoop systems various versions. So 1.x and 0.22 and 0.23 secure authentications are there and old configuration names, and we already saw that what is the difference between old and new APIs difference. So there we have, so configurations we have here, and deprecated and deprecated here, and new configurations, the 1.x there is no thing, new configuration names are not available, and 0.2s and 0.2s, and old map reduce API yes deprecated. So, such type of features are developed in HDFS. So based upon the, I think we know that once we are going to be installed HDFS, so user have a capability of that is a configuration capability is available, so that the person who is going to be use this application, they can easily navigate all those operations and they can go according to this. So about this book, we don't want much about this one, and this one is about this one. So next, second chapter is about map reduce. So what is a map reduce? What we are going to be do the map reduce? The map reduce is a programming model for data processing. Map reducing is a, so can read it once again. So whether what I told in previous, whether it is matching or not, you can think that. So MapReduce is a programming model for data processing. A model is a simple and yet not too simple to express useful programs in. So Hadoop can run MapReduce program write in Java, Ruby, Python, and C++. The most important and MapReduce programs are inherently parallel, thus putting very large scale data analysis into into the hands into the, into the hands of anyone with enough missions at their disposal. So MapReduce comes into one larger data set its stand looks at once. For example, if the MapReduce program itself, they have a own data set, large data set, that is weather data set. For example, we will write a program to mines, that is mines means we are going to be conclude simple meaning, weather data. So weather sensors collecting the data very every hour at many locations across the globe, uh, greater a large volume of log data. You know what is the log data? What is the log data? So we, for example, the last previous data was updated in particular time. The new data is updated particular time. So every the data which is at which time it is produced, everything is going to be recorded. That is simple meaning of log data. So which is good candidate for analysis in map reduce, since it is semi-structured and record oriented. Semi-structured and record oriented data. So we can easily analyze it. Then how it will be the data format? So I already told you, and I went to this website also. I shown you what is the data set, how it will be. Have you remember, or shall I go once again? So in year wise, okay, see that. Is it possible? I think my screen is not visible. So the data is going to be recorded in day wise, year wise, and month wise. So this was a website, National Center for Environmental Information. So how it will be, how we are going to be see that environment and information, how it will be. So data access, for example, we can go to data access. So you will see the search for APIs, access service APIs, we can search it. So, so somewhere we can have all this data, how it will be. Google log changes, see the text file. So see that data search example request. So we can get a common data. See that how the data will be. Now, if you are aware about what programming we learn from the pig and this hive, so can anyone say that what is this? So how it will be? See that every data is going to be divided, and we have some braces, we have some commas, and we have some colons. So can anyone say that what is this? The representation of data is different, no? So it is like a line by line, line by line, line by line. You don't have any proper order. So how it will be? So can someone say that, for example, what will be that? For example, here we started a bracket, and somewhere where we ended. Can someone check that where we ended? For example, somewhere we ended now. So maybe here we have started. For example, here. So okay, we so see here. So which I was selected. So what type of data this one? I think the data is clear to visible to everyone. I think so. Now tell me what is the data which I was selected? What type of data that one? So we know about what are the various types of data types. So there is a primitive data types and the complex data types are there. So I selected data. What is that? You don't think about what is the meaning of that data. Just tell me what type of data type that is. Can anyone? So brackets are there, flower braces are there, double quotations are there, commas are there. So what do you do? So we know that the representation of data in the different forms. So we may represent in a bracket, we may represent in a flower braces also. So how it will be? Map, no? Map data. Map data we are going to be represented with the square bracket. Flower braces, bag data. So in particular, one field is going to be called as pattern. So for example, if we were divided with the comma, so that maybe when we are going to be taking a program, when we are going to be displaying a table on column manner, so the data is going to be divided. So see the data is available. So what happened? So maybe it is for example, see the coverage. So this is the starting time and ending time this one, and data range. Again, data range colon, we have again a subset. So that is the bag may contain inner bags. You heard the word about inner bag. So that's, so you see some other data model there, data types. So how it will work. So we are going to be bad request, internal bad request, how it will. So everything there defined. So see here the data will be in different formats like this. So I already shown you some. See here again, data is an XML format. See here. Second. I already shown you some rows and data, year wise and columns. Server weather data inventory. So all the sensors, how they are mapped, data access. Message. See that we can, for example, we can see in the 2020. So how we are going to be all the Strom cells are the high signature cells, the all high signatures and digital various formats of data set. How we want to. So for example, all cells and reset we can give. So the representation. So see that this is the log. The period record is 1992-72. This up to now we have a record. Period of record. So 1992 నుంచి 2002 వరకు రికార్డ్ అయింది. సో 1912. So today is what is the date? 22. So before 19. So 3 days back వరకు మొత్తం డేటా అనేది రికార్డ్ అయింది. So how we want to see the data. So here I think I have a less bandwidth. That's when it is loading map is taking very. So see that what is where we have sensors that to collect the weather data set, that is so here we have bulk download, all those things we can do. It will take a lot of time to download, not a single data set. So that's when it will take large. So I think you have an idea about what is NCDC. NCEDC use the data about the national environmental. So total how to access the data. So this is like a open source, how we can get a already predefined data. So we can access these data and we can do some of the applications oriented data we can perform on this HDFS system. So example, for example is a simple line with some of the silent fields highlighted here. The line that has been split into multiple lines, which we here, for example, this is the data. So format of National Climate Data Center record. So we have here, so some of the fields, and we have USAF weather and WAPN weather identifier, all those things identifiers are there. So this is the one simple line how we do. The data files are organized by date and weather stations. So there is a directory for each year. So from 1991 to 2001, each contains a zipped file. So zipped file whether the data station is recording the data lines. So this is a, for example, we have first entries of 1990s. So 1990s we get it. These are the files. It is a GZ is zipped files we can call. So zipped files we have. Since there is a 10 of thousands of weather stations, the whole data set is made up of a large number of relative small files. It is generally easier to more efficient to process a smaller number of relative large files. The data was proposed so that each year regarding where we have concentrated into a single file. So this means we which was this carried out the described. So later we will see that the appendix, see what will be the described. So analysis of data with Unix tool, how we are going to be analysis. What is the highest recorded global temperature each year data set? So we want to know, find out what is the maximum temperature overall world in a particular year. Where is the maximum temperature? What is the maximum temperature? We will answer to first without using Hadoop. The information will be comments baselines. We will use means check our result. In a classic tool, we will use data awake. Simple example, we are running weather data set, a program for finding the maximum data set, and we will write some the comments, and we will find out like this. So temperature at what size in a particular year we can find out. The script loops uh, through the compressed year files. File first printing the year, then the processing the each file using AWK. The AWK script is extract the two files from the data and the air temperature and the quality codes. The air temperature value is turned into an integer by adding 0. So how we are going to be adding 0 to the previous data. Next, the test is appealed to see the temperature and it is valid the value up to 4 nines. Satisfy the missing values from the NCDC dataset. The quality code to indicate that the maximum value indicates that the reading is not a suspect or erroneous code. So the reading is okay, then the value is compressed with the maximum value seen so far. So which is updated to the new maximum founded in the end block executed after the lines files have been processed, and it prints the maximum value here. So here being we can run it. So we are going to be run that maximum underscore temperature one file one program like file we are going to be running. Then it will show us in 1991 what is the maximum temperature, in 1992 what is the maximum temperature, in every year what is the maximum temperature we can. The temperature value in such files are scaled as a factor to 10. It worked out the maximum temperature is 31.7 degrees for 1991, where a few readings at the beginning of in this century, if plan is good. So the complete run per century took 42 minutes in one run in a single EC2. The high CPU extra large instance. Okay. So to speed up the processing, so one simple thing we have to provide, it will take large time. So to speed up this process, we need to run a part of the program in parallel. So in theory, this straightforward, we can could process the different years, different process using all the available hardware threads on the mission. There is a few problems with this, however. So by taking a one single file, from that file we are going to be read the data and we are going to be set at the maximum temperature. It is not only one file. We have a different file sets are there. We have different zip files are there in a different years also. In the same year also we have a different files also there. So if you want to run all those things in a parallel, and finally we have done. So for that only this Hadoop map reduce program is came into picture. The first we divide the work into equal size pieces. Is not always easy to observe. In this case, the file size is different years, varies widely. That only, for example, if temperature is changing, for example, from morning to evening, we have the same temperature is carried out. So there is no much time to record that one. So from morning 9 to evening 5, we have the same temperature is recorded. For example, a different temperature. For example, morning we have a very high sun, and afternoon we have some a little bit rainy, and again we have again sun, again we have some cold. Whatever the different temperatures are noted, then as usual we have a, a large the data also producing is very high. So that is, we cannot say that each and every file has the same data and the same size of data. So that also we need to think about that. So even if they further work, the whole run the dominated by their longest file. So the better approach all those then requires more work. The split into, so the words will come. So the split into fixed size chunks and assign the chunk to process. The second we can combine. So what we are going to be do the map reduce process. We are going to be do the mapper. That is, we are going to be do the split operations. Then we are going to be do the combine operation. Then we are going to be do the reduce operation. Finally, we are going to be produce the result. That is the operation. So see that we are going to be split that fixed size chunks, and we are going to be combine that independent. We need to process that. In case the result for each year is independent with the other years, you may be combined by concentrating all the result. Maybe in one year we have a different again, uh, different same different temperatures, even if it is same producing, then again we need to combine all those things. That is how. And sorting by the year. So again, we need to sort by the year by using a fixed size chunk approach. The combination more is delicate. So for this example, a particular year, we typically be split the several chunks, and each processed independently will we will end up with the maximum temperature with each chunk. So the final step is to look forward the highest of these maximums. So for these years, so the third still be limited to process the capacity of a single mission. If it is a better time to achieve the 20 minutes with a number of process you have, then that you then that's it. Now you can not make it is go faster also. Some data growing beyond the capacity of a single mission. So we are not going to be solve it in a single mission. If you want to solve in a different missions also, so when we start using a multiple missions, the whole host of other factors come into play. So mainly the falls, the category of coordination and reliability. We run these overall jobs. Maybe for example, uh, I am running one MapReduce program here. Some other we are going to be some other place they are going to be run. So for example, I am going to be calculate overall data in each and every city. For example, in India, I am going to be calculating. So same application they are going to be use some other. So final data again we can use to combine, and we can that is a coordination we can perform, and we can release a total world. For example, you can consider in a one data set is not going to be produced by one a single sensor. It is going to be produced by multiple sensors. So then, so we are going to be take it as one, for example, one country or one particular sensor we are going to be consider, and we can have these map reduce operations. Others are going to be performed. And finally, we are going to be combine again all those things, these individual missions, and we can keep it in one single mission. So that one it is dimensions here. Individually, they are going to be performed. So I trust that word also independently. So we can call each process independent. So each and every system is going to be called independent. And it's going. So analyzing with data with Hadoop. So this way that map reduce program came into a picture. So generally, if we want to perform, so we need to download and we can perform all those things. So it is going to be do with a small number of files we can perform. So if it is on a multiple, we need to run some of the programs or some of the data sets are parallel. So in order to process this one, we are going to be use a map reduce program. So for performing this operation, Hadoop is going to be used a nice platform to run all these jobs. So so we will see that how to analyze the data with map reduce. So same how the data is going to be considered. I think this example only we saw, if you have a remember. So these bold things are going to be used as a year, and these bolds are gives the what is the temperature in particular year it will use. So lines are printed in the map. Okay, we will see the next class. So I think this one, for example, these four numbers will use the temperature. So the one is common for all. So that's only the first four digits is going to be used the temperature. So 0, 22, 11. Okay. So minus 11 and triple one and 78. So we'll see in the next class how we are going to be performing mappings. The same thing only shown with your PPT also. If you remember, you can cross check once again with your PPT and come by tomorrow class and we will discuss again. Any doubts you can ask me. Okay, thank you. We'll see you in the next class.